As I've been helping some in-person learners this week with these dilation assignments, I've realized just how difficult they are. So I'm going to record another video of me working through some of these problems, hoping that you can go back and do them on your own. Okay, so for every problem, you've got a blue triangle, ABC, which is staying where it is. And then you've got the green triangle, which is movable. We want to move it to create triangle A prime, B prime, C prime, though it's not labeled that, so that's not a big deal. Now we are using P as a center of dilation. So we have to make sure that everything we do has to do with point P and changing the shape toward that point, halving or thirding or doubling the distances from each point of our triangle ABC to point P. All right, so in this case, we are doing a scale factor of 1/3. That means we want all distances from points of our triangle to point P to be 1/3 of what the blue one is. These are all really tricky on this particular problem because everything is a diagonal distance between the points of the triangle and point P. So use maybe the corners of the green triangle to help you out a little bit, just to count through. So if I count this distance from point A to point P, I'm going up 3 and over 6. Well, I want 1/3 of that. So 1/3 of up 3 over 6 would be up 1 over 2. The problem where I just put that is that's actually 1/3 of the way from point A to point P. We want the shape itself to be 1/3 of the amount, so we actually need to move it again closer to P, up 1 over 2. And again, the reason I'm going up 1 over 2 is because from point A to point P was up 3 over 6. And 1/3 of 3 is 1, and 1/3 of 6 is 2. So see how my new point here is 1, 2 to point P. That's 1/3 of point A. So there's my A prime. Now let's look at point C. So point C is 1, 2, 3 this way, and 1, 2, 3, 4, 5, 6, 7, 8, 9 that way. Well, 1/3 of 9 is 3. 9 divided by 3 is 3. So I want to do 1/3 of that 9, which is 3. And then this direction is 3. So 1/3 of that direction, which is 3, is 1, because 3 divided by 3 is 1. So we've found our points for A prime and C prime, and I kind of can tell this because look at the length of AC, it's 15. And now look at the length of A prime, C prime, it's 5. And 15 divided by 3 is 5. 1/3 of 15 is 5. Also, this length A prime, C prime is parallel to AC. That's important as well. The sides of your new triangle should all be parallel to the sides of your old triangle. All we have left to do is find point B. We can do that the same way. Let's count. So 1, 2, 3, 4, 5, 6 this way. So 1/3 of that would be 2. So I'm going down 6 to count it, but then I'm going to go back up 2 because that's 6 divided by 3 is 2. Now this direction we have 1, 2, 3, 4, 5, 6, 7, 8, 9. I mean, they really do make these problems turn out with nice numbers. So 1/3 of 9 is 9 divided by 3, which is 3. So I'm going to take that back to there. So now let's double check our numbers. This number is 9.5, this one's 3.2. If I divide 9.5 by 3, do I get 3.2? I think so. And this one's 12.4, and this one's 4.1. If I take 12.4 and I divide by 3, will I get 4.1? I think that works as well. Also notice that this side is parallel to this side is parallel to this side, and this triangle is 1/3 of the size of the big triangle, and it's 1/3 of the way closer to point P. Use all those things to make sure your shape is correct before you hit the check button, because this will help you get the best score possible so that you can get a good grade on this assignment and not bring down your grade. Here, our second question says, triangle ABC is the image of triangle triangle A prime, B prime, C prime. It's the image of triangle ABC under a dilation whose center is P and scale factor is 3/2. That's a little tricky because 3/2 is 1.5. That means we're going to be creating a triangle that's bigger than the original triangle by 1.5 scale factor, or like 150%. So not twice as big, 200%, just a little bit bigger, but not twice as big, right? So here's point P is our point of, or our center of dilation. So if we're taking all of these lengths out by 1.5, that means let's take this distance and then go half more. So A prime would be about right there. Let me grab my pen. So if P to A is there, A prime, so that's like a distance of 2. So half of that is 1 more. We're going to go 1 more forward. So about right there. And then this here is about 3. So that means I'm going to go out to C and then go 1.5 more. And then this is approximately 2. And so I'm going to want to go, it's already at 2 out, I want to go 1.5 so of that. So this is 1 distance, so 1.5 distance would be about here. So my triangle would end up being blah, blah, blah. Can't draw with this tool very well. Should be using my tablet. I've got it right here. So I don't know why I wasn't using my tablet because it makes this so much better. So let's try that again. 1. Oh, maybe the tablet's not making it any better. I lied. Ooh, nope. Obviously I can't draw straight lines with my tablet. I don't know why I keep trying. Okay, you get the idea. This one's a multiple choice question, so let's look through for that triangle I was attempting to draw. And I really feel like that's it right there on C. Next, we have a question similar to the one we just did. It's just that this time we have a scale factor of 2. So instead of making our triangle bigger, we're going to make our triangle smaller. When I say it's like the one we just did, I'm talking about problem 1, not the multiple choice question 2. Okay, sometimes I know students like to actually line up the green triangle with the blue triangle. I think I showed that in one of my videos, and then take it from there. But that actually covers up my point. Look, the dilation is actually at point C. Well, guess what? If you need to move point C twice the distance from point C, it's still there because it's a distance of 0, and 0 times 2 is 0. So point C and point C prime are going to stay exactly the same place. That's convenient. Now for point A, notice how point A is over 1 up 4 from C. So if I want to double that, I'm going to go over 1 up 4 again. Now count these carefully before you hit check. You don't want to get them wrong if you can avoid it, right? And any little mistake will get the problem wrong, and you'll want to do the whole assignment again or take a lower score. Okay, so this one, to get this point to point B, I can take it back to C and count it if I want. Let's see, it's 1, 2, 3, 4, 5 up, and 1, 2, 3, 4 over. So I'm going to go 1, 2, 3, 4, 5 up, and 1, 2, 3, 4 over. So I've doubled these lengths. Now stop and look at it for a minute. I've got 4.1 and 8.2. That's doubled. I've got 6.4 and 12.8. That is doubled. I've got 5.1 and 10.2. That is doubled. This line is parallel to this line. And obviously these lines are both going in the same direction because they're actually just kind of on top of each other. So we have this smaller triangle, and then we have this larger triangle that's twice the size, and it's dilated from point C outward. Okay, one more problem similar to that. Again, we've got a point right on the edge. So instead, it's not at a corner this time, so it's a little bit different, but we do have the advantage that we have these lines we can count along, and depending on what our scale is, we're just going to take those numbers and multiply or divide to find our new values. Okay, so our scale factor is 1/4. So if you see the distance from A to P is 4, so 1/4 means I'm going to take that 4 and I'm going to divide by 4. 1/4 is the same thing as dividing by 4. So one of my points here is going to be, I'm not sure, sometimes moving these points around, they get stuck in place, so you have to pick different green points to get them to move to where you want them to be. But anyway, the distance I was just looking at from A to P was a distance of 4. So 1/4 of that is 4 divided by 4, which is 1. So I just want to be a distance of 1 from P. And then actually the same exact thing happens this way. So we have 1, 2, 3, 4 to point B. So 4 divided by 4 is 1. So our new point is only going to be a distance of 1 instead of a distance of 4. It's right on that same line. Alright, we actually have these 2 points in the right place, so now we just need to work on this point, and we just need to make it a 1/4 of where point C is from point P. So we can do what we've been doing on all of our other problems, and count from point, oh, is it going to not let me move it? There it goes, it got stuck for a second. I could count from point P to point C, or from point C to point P, and then go back out a 1/4 of that. So from point C to point P would be up 4, and would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to the left. So 12 divided by 4 is 3. So we're just going to go 3 to the left. And from P to C was 4 down, right? So 4 divided by 4 is 1. So we're just going to go 1 down. And that's where our point is going to be right there. So now step back and look at it. We've got this side parallel to this side, and that side are going the same direction. This side is parallel to this side. If I take 14.4 and divide by 4, I get 3.6. If I take this side, which is 8, and I divide by 4, I should get 2. I don't know where that number is. I think they're sitting right on top of each other, and I can't really see it. And then if I take 12 and I divide by 4, I get 3. So my triangle looks like it's a 1/4 smaller, everything's parallel, the numbers all match up, hit my last check, and I've got it. And I can screenshot that very beautiful 4 out of 4. Don't forget when you're screenshotting to include the title in your screenshot. That's very important to get credit for those assignments. Thanks.